Recording request. Thank you. Bridget, you unmute and pray for us. We start. Bridget.
Okay. Father, Lord in heaven, we'd like to thank you for this day. We'd like to thank you for the gift of life. We'd like to thank you for our teacher and everyone that is around today. We pray and ask that you enable us benefit from each and everything that is going to be talked about, and may we participate and be maximally attentive. In the mighty name of Jesus Christ, I pray. Amen.
Okay. Thank you for the word of prayer, Bridget. So, before we are going to handle some math today, but I wanted actually to first take you through how this mechanics is actually broken down. And then we see our plan, we break it down, something like that. So those who attended the earlier facilitations was a general facilitation about it was a general facilitation about math 2. We talked about how mechanics is actually examined. Then I remember saying that mechanics we all know that your paper has 16 questions, 18A and 18B. And we say that mechanics contributes 3 questions in section A and then 3 questions in section B. This is what actually happens, or that is what is actually done in the setting of mechanics or in the whole exam. Out of the 8 questions of section A, 3 of them are for mechanics. Out of the 8 questions in section B, 3 of them are for mechanics. Hope I'm understood there. So now the question is, we are going to now break down. The question should be, where are those 3 questions coming from? You understand? So I want to let you know today that mechanics actually also has division. That mechanics as a branch of applied math is divided into what we call kinematics. It is divided into what they call statics. And we also have what we call dynamics. So the second are called statics, not statistics. Then the third called dynamics. Now, following the fact that they set 3 questions of mechanics in each section, and on top of that, mechanics is having 3 divisions, that is clear, that is very clear that we have a question from kinematics in section A, we have a question from statics in section A, we have a question from dynamics still in section what? Section A. Additionally, we have a question from kinetics in section B, a question from statics from section B, and a question from dynamics still from section B. Something like that. So that means that as you're reading this mechanics, don't read anyhow. You read part of kinematics, part of statics, part of dynamics. And those parts you've left in bits, that's what your neighbor said. That means you'll be stopped out and you hate A level for the rest of your time. Because according to you, you'll have put in all you could, not knowing that you were just covering parts and parts. But if you're this student who is going to say, let me cover these kinematics all and I complete, statics all and complete, so that wherever corner or wherever direction the examiner takes in statics, I can attempt. Whatever route the examiner takes in kinematics, I can get them. I told you that these questions actually got out of stock. That's why they were looking at transition of curricula. Questions got out of stock. I tell you, if you're going to be this kind of candidate who is going to do a lot of questions in next year, then you're not going to find anything new in your name. Questions are the same, they just change the grammar. Examiners are out of tricks. That's what I can assure you. So the goal is to do a lot of questions. So because there are people who have glitches in perfection, you tell someone perfect these two, the person says, what if they bring them when they are hard? So for you want to cover all of them, but when you've not perfected, it is always hard to perfect everything taught at A level. You just need to choose certain things strategically and now get to know that I'll stick to this, I'll stick to this. Because at A level, I briefed you already that 68% is the same as 100 at A level, because this is a D2, the other one is a D1. And it is relevant to get a D1 at A level. So as you're going into A level, forget about D1s. They literally don't work. They don't mean anything at A level. All we are working for is a D2, which D2 is a 68. And that is our goal. Okay, let's say 70. 70, that is a sure. It can never be a C3 unless it is chemistry practical. Otherwise, it is a super D2, and that's all we need. So when I talk of perfection, please remember that. So the question should be, what is actually set in these things? I want to remind us that the mechanics has 18 topics. 18 topics. 18 topics that are supposed to be studied. 18 topics that are supposed to be studied or taught at your level as per your syllabus. You remind me tonight, I want to share those syllabus books. So, how many topics are in kinematics? Kinematics, the topics, according to your syllabus, they are 5. Statics, how many topics? According to your syllabus, they are 5. Dynamics, according to your syllabus, they are 8. If you know math very well. If the total is 18 and the first two are 10, then of course the other one takes 8. Yeah, you will find so many books having variations, but most books follow the physics. But according to your syllabus of math, that's how the topics were actually organized. 5 for kinematics, 5 for statics, and then 8 for dynamics. So after that, let us now look at the content of each. What is in kinematics? What is in kinematics that from which they get a question on section A and a question on section B? So we are going to come and say kinematics as our first section. So in kinematics, I've said the topics are 5. What are they? Have introduction to vectors, have introduction to vectors, have linear motion, or what people call motion in a straight line, have motion under gravity, have projectile motion, Then we have relative motion. Relative motion. Then, so those are the 5 topics for kinematics. Said there are 5, and from those 5, that's where they choose a question from section A and then a question from section B. So we go to the next one, statics. Also 1A, 1B, and also here, the topics are what? Even here, the topics are 5, you must be aware. So what are those 5 topics? You should be aware they are also 5. And let me tell you this, I always tell you that if you want to recall certain things, at least recall their number. If you know that the topics of statics are 5, you always recall to mention them, because you actually need this as you're going to revise. It is not something you should be taking lightly. So we have composition and resolution of forces. You people have heard of equilibrium of particles, where we get the Lami's theorem, where we use the parallelogram. You people have heard of the equilibrium of rigid bodies. You people have heard of moments and couples. You people have heard of center of gravity, and those are the 5. Those are the 5, and that's what they look at basically. So, what have I said? Statics have what we call composition, and resolution of forces. Composition and resolution of particle, equilibrium of a particle. So this is where I have said, this is where you find the Lami's theory. So you also use the parallelogram. Such things. We have what we call moments and couples. Then the 4th, equilibrium of rigid bodies, here where we find ladders. This is one of the most interesting. Equilibrium of rigid bodies. Of course, that one is added after moments. Equilibrium of rigid bodies. Then lastly, we have center of gravity. Center of gravity. So those are the 5 for statics. Now I can talk about dynamics. So dynamics, they are 8. Dynamics, where I have one question in section A, So one question in B, by these topics, actually 8. So the question is, what are those 8 topics? So all the topics that you have ever heard of and are not yet part of what we have mentioned, that's where they actually fall. We have force and Newton's laws of motion, we have connected particles, we have work done, power and energy, we have linear momentum, we have motion in a Cartesian plane, we have simple harmonic, we have circular motion, we have elasticity. All those are the 8 topics that are studied in dynamics. So what have we said? We have said force and Newton's laws of motion. Force we have force, Newton's laws of motion. We have connected particles, or the motion of connected particles. Have work done, power and energy, linear momentum. Yeah. So in connected particles, you can find their inclined planes. In work done, you can find their uninclined plane. Newton's laws of motion, you can find their uninclined plane. So the inclined plane is everywhere. I already see people mentioning it as a concern, but it is actually everywhere. We have work done, power and energy. Then talked of linear momentum. Talked of motion. Motion in a Cartesian plane. Then we have simple harmonic motion, elasticity, then circular motion. We have elasticity. Then we have lastly circular motion. So those are the 8 topics that fall under dynamics. So as a candidate, you have to look at all the 3 sections, because now you've heard of some, there are those you have not yet heard of. So it is upon you as a candidate to look at all the 18 topics and be like, remember at A level, things are supposed to be handled in bits. You cannot just handle things at once. You're not going to perfect any. All you'll be having shall be ideas on each, and my dear, that one cannot help you. That I assure you. It cannot help you even at any one moment. So, today I told you that we may learn a certain concept still in Mechan. Yeah, we are going to learn a second concept. But before I actually, before I go any further, I want to talk about something, maybe what was said last year. We see in accordance to last year's paper. What can we say about what we are? Can we compare what we have just said with what was said in last year's paper? I sent you that paper, so I want us to actually compare and see, and you see what I'm actually talking about. So you go to that paper. I sent it, so I don't expect people to. Let me resend it. Let me resend it to your groups so that people can actually see it. We are going to, I want us to be slow. I don't know why we panic. We have our time. So then I'm going to give you an assignment of you going through the question bank and actually confirming that what we have said is right for all, is actually right for all exams that have been coming before. So I've forwarded again that paper. You can check all the groups. So you go to section A. I don't know whether people have opened the script. You go to section A. We are just looking through mechanics numbers as we look at what I've just pinched on the screen. We just confirm and see whether it is right. Let me also open it here. So when we go to section A number 2, who can tell us? Who can tell us in the chat? Someone raise up your hand, and if you're ready, you raise up your hand, we teach together. We are just going to identify. I think we are going to get 2 papers. Told you that I don't have anything that is going to make us panic. I want us to come up with a plan when actually people have confirmed. I think I should actually get more, like 2 more. They're the ones we are going to use. So someone tell us, number 2. It was set from which section? Number 2. Number 2. From which section was it set? No one is going to tell us. I've resent the paper. And I'm talking of number 2. It was the first number of mechanics. From which section do you think the number was set? You see, people are still confused. Someone has said dynamics, another one statics. Anyway, this is the thing. The question is talking of a force P and they are giving you an angle. So that means we are going to do some resolving. So that is statics. So have you seen the one question of section A for statics? This is what we are going to identify. We are going to use some papers. Let me meanwhile get them. So you have seen that number 2, they wanted some resolving to be done. Now number 5, who can tell us? Number 5, from which section? When you're mentioning the section, at least mention the topic. You say this topic under this section. Number 5, you can see they are saying a force acting on a particle mass. They are giving you the position vector. They are giving you R. And those are the things I'm teaching you today. That's what I want to talk about today. So I want people to tell me what they are thinking as I get here more papers. I wanted unique papers, but I think we can now try with the mock papers. And now someone is saying kinematics vectors. That is not correct. That is not correct. That's why I want you guys to learn these things today. I want you to be in position to look at a question and be like, this one is coming from this, even when you've not yet studied. I'm not seeing the question. Maybe people, I think I should also expose for you the paper here on Zoom. Is it disturbing you? Is it disturbing to be checking the thing on phone as you follow up? Okay, let me do that very fast. Yes, we have our time. We are not going to panic. Let me get the paper. I think it has reached. Someone has said it's quite disturbing. Okay, we are getting a solution. So you look at now my screen. I think you can now see the paper. So I was talking of number 5. We began with that number 2 you're seeing. So I think this is going to be better. And I said the question gave us a force and the question gave us an angle. That means we like it or not, we have to do some resolving as a must. So we say that this one is falling under composition and resolution, which is statics. Statics strictly under composition and resolution of forces. We're even talking of the resultant. Composition, forces. Composition and resolution. Then I was talking of this number 5. Now I don't know how you're going to do it. So that means you must have noted, yeah? Because that is number 5. Again, those are our branches. Those are our branches. The other one is number 5. So I don't know which I should expose and then which I should leave. I think it will disturb us a bit. So number 5, I want people to think. Anyway, number 5, let me brief you. Because people may not be having ideas, most of you. So we agreed, those who studied vectors, we said that this I is a unit vector that represents the x-axis. Then this j is a unit vector that represents the y-axis. And you know these things actually are found on what you locally call a graph and what we call a Cartesian plane mathematically. let me hope people are aware that a graph is actually a Cartesian plane, and they are talking of motion. So of course, without a force, we can't have motion. So this is actually motion and or in a Cartesian plane. So I think you can see that where is falling. Have you seen the second topic? Actually, it is the fifth under dynamics, that one of motion and the Cartesian plane. So that's where that one is found. So this is in dynamics, and it is motion and this Cartesian plane. So that means we like it or not, the third number should be coming from kinematics. And it is here. So let us confirm, is it actually kinematics? Number 8, if it is kinematics, which topic? Which topic? Which topic? Which topic? So every time you see these things, you just look at those topics under kinematics. You can literally tell the topic from which it was obtained. Look at those topics under kinematics. By the way, someone with the any math 2 paper, you can send it in my inbox. Any. I want someone to be saying, maybe for you are getting your own papers which are favoring the format. So let me send another paper, and I also expose it here. Yes, we are going to have very many papers. Let me send you take paper 2. Okay, so this is a question every time you see people talking of crossing a river. So crossing a river is a topic in relative motion. Or in simple terms, every time you see motion of two things being studied, you know the meaning of relative motion means something is moving relative to the other. You understand? And here they are talking of a boy and the water flowing. Yeah. A boy swimming and water flowing. So that is always relative motion, trying to study motion of two different objects. So, and this one was under kinematics. Yeah, kinematics, a question in A is there. And for this case, it is relative motion. I want us to plan when actually members have really confirmed that the breakdown is real. This is the first number of mechanics. This one. A ball was thrown with this velocity vertically upwards. Vertically upwards, that is motion under gravity. And we find that under kinematics. Kinematics. Motion under gravity. That is kinematics. So that one was secured. The one question of section B was talked about. Then this one, number 13. Let me hope we are at the same page. Eh? The other one was obvious. Number 13, what are they talking about? They are talking of inelastic string. So the topic cannot be elasticity. So, what do you think? Which topic is that? Which topic is that? It cannot be elasticity because this string is actually inelastic. Is actually they're even saying a circle, circle. Yes, we have what we call angular speed. That one is only circular motion. Every time you see angular velocity, angular speed, it is circular motion. So now this one was dynamics, and the section B question was secured. That means the question that is supposed to be coming next, we like it or not, it should be a question of statics. Because of circle, we have said circular motion. Every time you see anything angular, same thing, you think of circular motion, which is falling under dynamics. Said circular motion. Cannot be linear motion. Lastly, number 16. What are they saying? Center of what? Center of gravity. Which center of gravity is found under statics? So that means even statics for section B was also secured. So I think you've seen from a UNEB exam, the thing is actually coming out. So we have a mock paper that I've been sending. It is you take. I also want to talk about it. We see if it is also holding. There are always a few things that may not rhyme, but they are less than 5%. If it is a national exam, it will always work out. But these mock bodies are always fun. But I've just picked any random one. So we are going to stop on the you take one, then the rest shall be your assignment. You can't actually confirm. Is this actually working out? So I think you can see. For section B, we had the question statics, then dynamics, then kinematics. Section A, you can see statics, dynamics, then kinematics. Section B, kinematics, dynamics, then statics. Something like that. So, what of the take paper? What of the take paper? Very fast. Here. It's 2024 also. Let us go slowly and see. They are saying that a particle executing simple harmonic motion, we saw it under dynamics. So dynamics, the section A question has been secured. Voice breaking, is it my network or yours? I don't know, you can let me know. It's covered in another question. Another question, they are giving us the position vectors. They are giving us the position vectors of two bodies after 30 seconds of motion. Then they are telling us to calculate the shortest distance. The shortest distance. The shortest distance. I don't know whether people are aware of that. Do people know what actually is talked about for the case of shortest distance? Every time they talk of shortest distance, teacher, how exactly does kinematics differ from dynamics? Because apparently both involve motion. It is different in a way that we have divided those topics. Actually, dynamics is like a continuation of the other. The other one is more basic, yeah, than this. But it's different in such a way of the way the topics are being distributed. Yeah. So here, the shortest distance, this is something that is studied in relative motion. We know relative motion, we see this in kinematics. Then we saw the question ready for dynamics. What next? They are saying a particle is projected vertically upwards. This is still kinematics. That's what I told you, that for these mock papers, you can have a glitch. Now realize in section A, they didn't set anything concerning statics. But remember, your papers are modulated. You know very well that statics means we don't have motion there. As you can see, please, Maniratiza, you remove, thank you. So, you know very well that statics means we don't have motion, and all these questions actually involve motion. Hey. So for this case, it is kinematics time to shine. Projected vertically upwards. That is the second question for kinematics in section A. Remember, it is also having another one here for shortest distance. The shortest distance is taught in relative motion, and relative motion is under kinematics. That's one in A, and the second one also in section A. So we go to B. They are talking of center of gravity. So you know that now number 10 is talking of statics. Statics. One question of section B has been secured. Proceed. What next? You see what is funny? This is equilibrium of rigid bodies. Equilibrium of rigid bodies. Again, statics. Hey. So I think you see, after this examiner refusing to set statics in section A, the examiner came in section B to set two questions of statics. You understand? I've told you that your papers are always modulated. So, of course, the chances of having better days is higher, in that the paper will come balanced. So let us see the last question. I think you can see these are rigid bodies. Someone may be like, how have you known that they are rigid bodies? They are terms that you're going to be learning as we progress. Words like hinged, just see that. Words like inelastic, you can now tell and be like, oh, these are now rigid bodies. Then the other number is here. Guess what? Here they are talking of part A belonging to dynamics. Because you can see a concept of power, work done, power and energy. You're seeing constant resistance. Those are things taught in friction. That is all under dynamics. Then again, we can see part B, which now part B is talking of the shortest time. I've told you shortest time, shortest distance. This is now relative motion also. So now part B is again from a different thing. It's coming from kinematics, relative motion. So I think you can see how biased the examiner was. Kinematics, relative motion. So that's why I always tell you that perfection will always work out, you like it or not. So if you find that for you never perfected that concept for power in dynamics, you can come and do part B out of the 7 marks. Even if you get 4, they are enough. They're enough. I already briefed you about the other branches in paper 2. So you getting here 4 marks, even if it is out of 12, it is not bad. The goal is not 100, because the more you aim for 100, the more you reduce time that you will have used to perfect those that could get you a distinction, which distinction is also can also make you get that you're actually striving for. So the assignment I'm giving you is to go to those other papers. Now these are things we have been doing, random variable. So I expect someone to surprise me with answers to this. You go for this number that you take paper, I've shared it. You do the whole of that. These things of percentiles, probability, finding capital F. Those are things we have been doing. So hope I'm clear there. Hope I'm clear there. So realize, and if you're to recall, so I'm done. Those sample papers are enough. They are enough. So I remember showing you that if you look at these mechanics, you have 3 questions in section A, but each question carries 5 marks. That is 15 what? Percent. Then when you go to section B, there are 3 questions, and each is carrying 12 marks. That is 36 what? Percent. Get the total. That is 51 what? 51%. So if at all you are a student who has perfected these mechanics, which is very possible, especially for physics students. Physics students, you have no option. And please make it a routine. Make sure you have these 51 marks at hand. Because most of the things that disturb biological students, you know. Most of the concepts that disturb students who do MEG, MIA, me, you know them. The elasticity, the simple harmonic, the circular motion, the linear momentum, work done, power and energy. Those are things that disturb most biological students and others. So for your case, at least make sure that these 51 marks are secured. As a physics student, make sure they are secured. So that means that for you don't have any option apart from knowing all theory. You people, I assure you, dynamics is not easy. That one, I'm telling you from experience. Dynamics is not easy. Someone is saying projectiles. Projectile motion, I talked about it. It is in kinematics, it is the 4th. It is here. So I want to tell you, how do you find yourself failing math 2? You be there saying that, yeah, I'm now going to do kinematics. Do you know what you do? You come and cover only these 4. You leave out relative. You name sets relative. You come statics. You do all of those ones and you leave out center of gravity. And you enable brings the center of gravity. You understand? Here you left out relative motion. That's what your name brings. Like this one, it came in 2022 when no one expected it. And that's what people leave out. Center of gravity. That's what most people leave out. Guess what? It came in 2023 and also came in 2024. Then they come here. Most people leave out circular motion because it is hard, especially for biological students, but physics students do it. They leave it out. It came in 2024 also. We have just seen the paper. And that means, you see, this A level is not fair at all. That's why these people are actually fighting hard to change curriculum. Just imagine, dynamics are 8. You come, you waste 2 terms, you are perfecting this, you are perfecting this, this, and this. And maybe you get caught up by time and be like, the good thing I've done the 6, let me leave the 2. And your neighbor comes and says out the dynamics, the question we are picking is circular motion. That's how you get stopped out. But if you're this student who had it at the very beginning, that for me, I'm supposed to do dynamics no matter what, that means there is no way time is going to catch you up. That means you will have enough time. Do the whole of dynamics if at all that's where your passion lies. Do all of them, make sure they are perfected. Get like 80 papers. Let me tell you, social media came and saved most of our lives. Most of your lives has been saved by social media, academically, social, and so on. Papers are all over the internet. If I just decide to send whatever is in my phone, I don't even think that 80B is enough, because a lot, I have a lot. Papers are so many, you cannot complete them. Even if you just get 100 papers, just to confirm whether you are on the right track, you just be like, I'm really focusing on this dynamics, but has it been actually happening? Can I really confirm that yes, there is a number on dynamics in A and B in every paper? If you just confirm that, then you know that I'm on the right track. Then you just need to keep reading and pray about it, that actually your plan is favored as the paper is being chosen in moderation. So, what is my advice? Physics students, make sure you know everything. Whatever you do in paper 1 of physics section A mechanics, just apply that knowledge here. You are not going to find issues in paper 2. Biological students, you like it or not, this one I'm repeating, you like it or not, you cannot master the 3 sections of mechanics when you have biology, when you have chemistry. That one is not going to happen. That one is not going to happen. Please and please, choose any 2. Which 2 I advise you? Kinematics and statics. When you have perfected them, after perfecting them, you come and handle these ones, but strictly handling questions of section A, which is very possible. I calculated with my math 2 mentor, and he told me that a student who has done kinematics and statics, and they have really given in their best. Remember, kinematics and statics, it is a total of 10 topics. Dynamics alone is 8 topics. First and foremost, it is sensitive. Second, topics are so many. You understand? Thirdly, you cannot mix it with the other ones. Why? Even the other ones have heavy topics. Relative motion is very sensitive. Center of gravity needs a practice. So what is my advice? Concentrate on only kinematics and statics. Only. Even if a teacher comes and they want to teach dynamics, you leave the lesson. You go and revise other things. You don't need 100% to get an A. Even when you have ideas on everything, those ideas are not going to help you. What is going to help is having perfected the concept, reaching an extent of finding a similar question in your name. People are out of question. When you exhaust all questions that are circulating on media, you cannot find any new question in your name. Senior sixes were complaining about their UNEB paper of paper 1. But that paper was not hard. Those were past questions in UNEB. But in those old years, 2000, 1997, they brought 4 numbers from 1997. You look for that paper and look at the current paper of 2024. 4 questions from that year were set. That means the setters must have used the same source. Which sources are the textbooks I shared in the group? Those ones of A.J. Sadler, the Backhouse. Those are the math Bibles they use as their setting. But math is all about having a technique. It is just enough for you to interpret whichever number. So my advice from today, you take my advice, you'll thank me later. Be in position to do everything in kinematics and statics, whether section A or section B. When you feel like here you've perfected, you come and make sure that you can do numbers of section A, purely section A for dynamics, even if you don't get that time. You'll see what happens. If at all that is your plan, that means, let us look at a student who has not done anything in dynamics. That person is at a risk of only 5%, because they will not be in position to do that one number of section A for dynamics. They will not be in position to do it. So that means they will be working out of 95%. I don't know whether people are getting me. If at all someone says that, what is the plan? What am I saying? If at all you decide and say, that, like I've suggested, that you're going to work on kinematics and then statics, you get? So you'll be like, my plan is kinematics. And why do I want you to concentrate on these topics? They are nice. Those vectors, unity vector, motion, linear motion, O level, motion under gravity, O level, projectile, there is a concept of O level still. So that means the only new thing in kinematics is relative motion. So you work on that so well. Then when you come to statics, same thing. Same thing here. Resolving forces, that is the easiest at A level. Equilibrium, Lami's theorem, and the parallelogram, very easy. Moments and couples, those are a bit technical. But the moment you understand moment and couples, then rigid bodies is a walkover. Then center of gravity, you need to do a lot. Only that. So if you work on this, that means you have 2 questions of section A and 2 questions of section B. Remember, the student I'm talking to is a student who is fine with all the other concepts of probability, statistics, and numerical methods. So that means you are at risk. What is the risk? What is the risk? The risk is that the one number of section A of dynamics you cannot do. So that means that is negative 5%. That's the only number you cannot do. I'm not focusing at about section B. Why am I focusing on A? Because all questions there are compulsory. But section B, out of the 8, you have 7 questions. 7 questions that I'm assuming that are doable. And still I'm saying, except that of dynamics. Except that of dynamics. What I'm telling you especially goes to those kids doing biology. This is now your advice. Those doing physics, you can even log off. You can start reading mechanics straight away. Because for you find this work in physics. So when you come in math too, you're doing more revision. But in my people doing biology, and those who don't do physics, please, this is for you and not for anyone else. So you cannot tell me that out of these 7 questions, can you really fail to pick 5? You people, even if you don't pick 5, even if you actually, your neighbor saying that you are supposed to pick 5. For me, I'm saying out of the 7, don't even pick 5, pick 4. Pick 4. That means even if you do 5, I'm even accompanying for marks for errors. So imagine you've done the 4, each is 12, that is 48. Then we have realized that in section A, you have remained with only 7 questions, each is 5 marks, 35. We are going to remove 35%. This is 48%. Here we are going to remove 13 marks for errors. That is 22%. The balance. Still you can get a 70. Here, let me assume you have been revising. And you have chosen the 5, each is 12, that is 60. So for me, let me say I'm removing the 12 marks for errors. So I'm removing the 12% errors. Even here, let me be same thing. Let me say 12 marks for errors. And this one is going to be 23. This one 71%. You people, in math too, this is math where you just need to be calm. There are very few concepts that actually come in this paper. So you are seeing that you have put at risk a whole branch of dynamics, but still you can be in position to get a D2. Very possible. And 12 marks for errors are so many for someone who has been practicing, especially for that section. Getting 23 in section A is hard if you have been practicing. Section B, you have sacrificed a full number. You've either done the 5 and you have mistakes of 12 marks, or you've done only 4 perfectly well and the marks are there. And you know, you guys, it is possible. Like a number of scatter diagram and rank correlation, you can get 12. A number of probability, you can get 12, especially if you're given a PDF. A question on NRM, Newton-Raphson method, they tell you show that this equation has a root between this and this. You get the initial root. You use NRM, you can get 12. Trapezium rule. Use trapezium rule, actual integration, get the error, suggest ways of reducing the error. You can get 12 marks. The disturbing marks to get up. But again, if you have been practicing, mechanics are the best numbers and easiest to do. When I was still in high school, I used not to do mechanics for the whole of senior 5 and I could get 80s because I had perfected these ones. I literally didn't know a thing in mechanics. But when I went to senior 6, I now got my plan. I handled these kinematics and statics well. The exact thing I'm telling you is what I did. But after actually studying a lot of papers, whatever I'm telling you was done. I actually did. Math, I remember going through around 613 papers. Not doing, but going through them to see whether my plan will favor me. And out of those 600 plus papers, almost 600 were in the favor of my plan. So I kept strong. And in the final exam, everything was okay. I did 2 numbers of mechanics. In my UNEP paper, I didn't do any number of probability in section B because they brought a velocity time graph. They brought connected particles. Then the other question was on resolution. Very easy things. If resolution and then moments. Then, but me, after doing the statics and kinematics, I had to go and see the numbers of dynamics of section B. I made sure that I know all of them. You check our year, it was number 2 and number 3. Number 2 and number 3, that's when they brought a question on momentum. And I did it also and I passed it. So literally, passing A level requires you to read smart. You need to read hard, but that reading hard must be accompanied by smart reading. Not reading just for formality. You've seen people who have actually read and have not made it. People who have actually read and have failed. Yes, 600 papers. 600 papers. Someone saying, which group did you share the papers? That group of all Ugandan students. I'll share you the link. You just remind me. Yes, 600 papers. So literally, and we have those people who don't need the A. There are people who need the B. And for you, your thing is so easy. You just need to add more marks for errors. Increase your marks for errors to 20 and 20. That means you're going to get a 60, which is a C3. C3 and C3, you get a B. And it can actually come out very well. Not just a matter of calculating, you sit back and wait for the calculation to come through. You have to calculate and then you start straight away. You read with a goal. You complete the first 4 topics in kinematics. You now read the relative motion with the urge, knowing that the goal is to make sure kinematics is sorted. After understanding relative motion, go through around the 20 papers. Confirm that each paper has a question on kinematics in A and B. After confirming that, now you embark on statics. Do it and do it. When you find issues with rigid bodies, you will not give yourself a chance to give up, because you know that I'm on a goal. I'm on a mission of making sure that every question in statics I can do. And you very well know that if I risk and leave the rigid bodies, even if I know the other 4, you never may pick this one. That means for the 2 years, I wasted my energy reading resolution, reading equilibrium of a particle, reading moments and couples, reading center of gravity. And one thing you left out under statics, which is equilibrium of rigid bodies, is what your neighbor has chosen. That is the most hurting heartbreak at A level. Leaving out something in a bunch and you never picks it, even when you knew that you're leaving it and it is part of the others you've covered. So please and please do the needful. Do the needful. That is what I can tell you. You risk that 5%. But if at all you finish the other 2, you can also come and work for the 5%. You only make sure you do the section A numbers of circular motion, only section A. And in so doing, a question can come in section B and it is also doable. We are just trying to reduce that stress of the dynamics numbers of section B as a biology student or as a student who doesn't do physics. So hope you find that important. That one will help you. So just combine this information to the information of the first facilitation. You come up with your plan. Thank God that you have the plan before you begin senior 6. Very few have it. Some of us got it by chance. And our friends didn't actually know this thing. They were just studying. You find a friend knows 1 topic in kinematics, 2 in statics, and 6 in dynamics. What is that? That is wastage of time. You only pass by luck. Which luck is one, it happens once in every 100 times. Okay. So unless someone has a question, but literally that is the simple facilitation for mechanics. That is the simple facilitation for mechanics. That's the way you can go. So do we have some questions? How can we, someone is asking, how can we be assured? What do you mean? You be assured by checking past papers. Yes. 600 papers, someone is asking, how did you get the hard copies? Now, what is wrong with getting hard copies? A paper of math can, if you compress a paper of math, you can have paper 1 on one page, paper 2 at the back, and that is only 50 shillings. That means I needed 30k to print all those papers. Actually, I've got it. Gonna use that strategy. The problem is interpretation. Interpretation disturbs one who has not been practicing. You're not getting my point. We are just not saying that we are not in a restaurant that they have given you a menu and they are telling you that pick what you want. That's not what we are doing. You have to actually choose, work on what you have chosen. That's when interpretation is going to become a walkover. Don't expect the interpretation to come just right now. These are things that have been passed. You're not the very first people to do them and not the last. So what I'm telling you is actually it. What I'm telling you is actually it. Is it possible for us to get some papers in the group? Yes. But I always give those papers when people have covered most work. So you get most papers in your holiday of first term. I'll give you over 1,000 papers in total of all subjects. Over 1,000 papers. You people, papers are so many all over media. All over media, papers are so many. Yeah. So but we are not in your group, sir. That group of Ugandan students, if you're not in the group, these friends who are attending Zoom with you here, they are in the groups. So they can literally help you connect you. Yeah, that's what I think. They can actually help connect you there. So, any questions? Any questions? So assuming I'm doing physics, I'm not interested in dynamics, can I still perfect it? That means even those topics of dynamics, you're going to fail them in physics. Yet physics is a must pass. You promised to share us with the link. Yes, you send me a message. My number is just there. You can even see it on the document. So you can send me a message and add you up. So if we don't have any questions, I think I can cover the concept I wanted to cover today. Yes, just want to teach people something about constant velocity, constant motion. I don't know whether people are aware of those concepts, but those who didn't attend the lesson of unit vector, you may get disturbed a bit. Let us pass display the course outline again. Okay. That is the math plan. Those who didn't cover the what? The course outline, I assure you're going to get disturbed. Please make for us a PDF for that course outline. How much can we really cover? Yes, I'll send the PDF. How much can we really cover under each? What do you mean? complete kinematics, complete statics. What do you mean by covering? It may help you. So today I want to teach two things before we actually sleep. On top of the facilitation, we are going to get some numbers we can actually try out. We want to get some numbers to try out. So Prince J, I've seen you complain about vector mechanics. And I told you that is motion actually in a Cartesian plane. And it's what I'm actually going to talk about. But let me hope you paid maximum attention in the lesson of vectors because we actually need it. Yes, we actually need it. So any other questions? Or we can start. And the person who told me to expose the topics, are you done? Someone is saying, how about connected particles? It is under dynamics. If all I wasn't able to be within, then how will I be helped? Yes, I will see how to send you the recording on that. So I think people's questions are done. So I'm just going to give you, it is exactly 9:30, and that's what I hoped for, so that we use more because we need 45 minutes to do what I actually want. So I'm just going to give you a break of 5 minutes. A break of 5 minutes, but don't log off, you stay on Zoom. Only a break of 5 minutes, then we start again. What we are going to cover, let me write the title. You can even, meanwhile, those who don't want to rest, you can go and find out what it is. So we are going to look at motion. Not to just teach you these numbers. They are so easy. So if they are part of you, it is nice. Teach you. Because you guys have just done unity vectors. So I believe they are nice. So motion and Cartesian plane, Cartesian plane, Cartesian plane, involving involving variable velocity and acceleration. This one we are just studying it just for fun, because people have just studied integration and differentiation. So even here, these things actually come back. Acceleration. We have just been doing integration. So we're just doing this for fun. Then later we shall embark on our plan. We shall now plan in the group. I find out which topics of statics you guys have done, which topics of kinematics you've done. I see whether we are going to just revise or there are those we need to cover. That will be after some voting. But for today's facilitation, you're going to leave this place when you have at least understood something on these. Motion under a Cartesian plane involving variable velocity and acceleration. So now we have just 2 minutes. 2 minutes to start. 2 minutes only. We have been in our break, of course. Okay, so I think now we can start. That is enough. Yeah. I've said ready to set off. Okay. Now, have it at the back of your mind that here we use the concepts of Newton's second law of motion. Then we use concept of calculus. And you all know calculus has a component where we do some differentiation. Then a component. So we are going to leave this place when we can actually try out some numbers. Just be patient. So I think we can now start breaking them down. For the Newton's second law of motion, Newton's second law of motion. Physics students, you know. What does it say? The rate of change of momentum and so on and so forth. Directly proportional. Force applied provided it does not proceed or take place in the direction of the force. Something like that. But as students, as refined students of Math 2, we simply say that the Newton's second law actually defines force. Simple as that. You all know that. Newton's second law defines force. But it talks of the rate of change of momentum as being directly proportional to the applied what? To the applied force, provided that change takes place in that direction in which the force is what? Is applied. So here, simply define the force, but we all know that force is MA. Then the other thing you have to know, anything to do with the Cartesian plane. Cartesian plane. Remember telling you that this is where we have the I and the J components. These are vectors. So this is something they call vector mechanics. Vector mechanics. Why vectors? We are talking of a Cartesian plane where the x-axis is represented by the unit vector I and the y-axis is represented by the unit vector J. Yesterday I explained as to why they are called unit vectors. So you know very well that force is a vector quantity. So we have to put tilde on it. We have to put that vector symbol on force because force is in the vector quantity. Then you also know that mass is a scalar quantity. So that one we shall leave it as it is. Then acceleration is a vector quantity. So we shall put that vector symbol. Those are two things that I actually wanted you to learn today. At least you learn that today, even if you log off now. But when you have slept, knowing that force is a vector quantity, so we put that tilde sign. Then also acceleration is a vector quantity, we put the tilde sign, but m the scalar quantity, so we leave it as it is. So from that we can actually tell, I can call this equation 1. So literally you can see that from equation 1, acceleration can be obtained by getting the force divided by the what? By the m. Yes, something like that. I think you can see that. So that's how the concept of the Newton second law can be used in what we are going to do today. I want to first break down everything for you, then we start some examples. Because the question will not tell you that here I use second law of motion, here I use this, here I use this. It will not tell you. Then maybe to talk about force, I can put here a note. And say, if forces F1, F2, F3, and F4 act on body X, what is the resultant force on body X, if I may ask? What is the resultant force on the body? I want someone to tell me. I'm asking, if forces F1, F2, F3, and F4 act on a certain body, what is the resultant force? What is the resultant force on that body? Anyone who can give it a try? I'm bringing in a note, but in form of a question. And that note is very important. Everything I give a red tick, just know it is sensitive. What is the resultant force in that case? You can raise up their hand and tell us, or you write in the chat. What is the resultant force? Their sum. Exactly. The sum of all the forces. So for this case, the resultant is the sum of the forces, and that's what I wanted. So you also give this respect every time you think of forces. It is something that always comes through in different questions, but you should not forget the concept. The resultant force, they always write it as capital F subscript capital R to mean resultant force. Then, if I'm to talk about the second concept of calculus, it comes in, I'll begin with differentiation. Okay. Now, those people who passed O-level physics, and also those physics students who are good at physics at A-level, I have some definitions for you here that I want us to try out. First question. Remember, we are dealing with acceleration and velocity. So I want you to define for me velocity first. Define velocity. You can define for us velocity 5. As people are planning to define for us, acceleration. You can define velocity. Velocity velocity is the rate of change of displacement. It is okay. You people should at least recall that that is the unit for velocity, which means meters out of seconds. So these seconds are a unit of time, then these meters are a unit of distance. But since velocity is a vector quantity, I will use displacement, because you know displacement is the same as distance, just because one is scalar and another one is vector. So those meters are for displacement and these ones are for time. And you all know that time is a quantity they can use synonymously with the word rate. Every time they say rate, you think of time. And you know displacement means change from one position to the other. That's why a friend is telling us that actually velocity is the rate. Actually, for me, I will not say rate, but I will say is the change of displacement with the time. With the time, or what a math student can make more specific and say that displacement is changing with respect to what? With respect to time. Remember, time is down, then displacement is on top. Then I want to teach you this, that in this math, I saw someone writing something. What are you writing? Or someone was telling us about acceleration. I've said I've left out rate. Yeah? When you use rate, you don't bring in time. When you use time, you don't bring rate. That's why I said they are synonymous. So you cannot use them in the same statement. So I want to teach you this, that in math, velocity, we are going to be showing it as v, but it's a vector quantity. So I'll put a tilde to mean vector. Then displacement, this way we call it r. Every time you see us using r, we are meaning displacement. And it is a vector quantity, so we shall put that. Then time is a scalar quantity. This one I'll just call it t without anything. Understand? Then acceleration. And acceleration is also a vector quantity. That one we have already seen it in the Newton's law, something like that. So give these things actually time. In math 2, which is applied math, they're actually given concentration. You make a mistake as you're writing them, kiba kikulidde. Yeah, that's what they say in Uganda. That will be the end of you. So you have to actually prioritize those symbols. Just don't underlook any. Now, we go back. What are they saying? Velocity is the change of displacement. So I want you to all know that in math, still, change has a denotation, which is, can be that delta sign, it can be the d, or it can be this. However, this one in most cases means a very small what? Small change. Small change. But I'm going to take this, which is the most common. Or I can call it usual. It is the usual one. So it's what I'm going to take. A small d. So I'll come and say, what are they saying? They are saying that velocity is the what? Change of displacement with respect to time, which is over time. But with respect, which means dt. If that makes sense, then you will be you are one of the best math students currently in the country. I told you I interact with almost 50% of students from different schools in the country. So when I tell you something, you just have to believe it. So does that make sense that velocity is the change of displacement with respect to time? From integration, you know, with respect to x is dx. With respect to time, of course, it's supposed to be dt. But we know time is the denominator in this case, according to the formula. Displacement over time. Change in displacement out of change in time. Because we know velocity, of course, keeps on changing. Why does it change? Because we are having a change in displacement and a change in time. So, is that okay? Is that formula okay? So you people, is that formula okay? Now we go to acceleration. Because now we are going to acceleration. Okay. And those are the formulas you guys use in math too. So they will actually apply so much. Okay. Again, physics students, who can tell us, actually someone already told us what acceleration is. Acceleration is the rate of change of velocity or change of velocity with respect to time. Exactly. So acceleration, I agree that this one is just small a, not forgetting that. So we are saying this one is the rate of change of velocity. For me, I call it the change of velocity with respect to time. What I can call over the change in what? Over the change in time. This one can actually tells it because acceleration has this unit. Meters per square second. That one, it is easy. That is the unit of velocity over the unit of time. So you have change in velocity over a change of time. Using indices, you can easily recognize, or you can tell that actually this is this. I will say that acceleration change of velocity v is a vector quantity out of dt, which is change in time. The moment you forget that vector thing, if you are in a serious school, they will cross you. Because usually during training it is emphasized. But at UNEB someone can forget. But if at all your paper lands into the hands of a rigged examiner, you're going to lose those marks. So as you read, you also pray. But the person who gets your paper is merciful. So we are going to need these formulas so much in whatever we are going to do. And you should know why we have those vector signs on a certain letter and not the other. So my question is also that formula of acceleration okay? I want us to leave this place when we can actually spot out UNEB numbers we can do. That is enough to show that the lesson has been a success, in that we are working on our goal. So do you make sense out of that cheat thing of acceleration? So that is all with part A under calculus, which is differentiation. I think now I can talk about the integration bit of it. Integration, if you didn't attend the lessons of integration, now this part is going to be hard for you. We're now going to part B, the integration. I know someone has been following, but now they are seeing part B integration. They are like, what do you mean by part B integration? I said that in these things we are going to do, we handle two things. Newton's second law and then calculus. Newton's second law, we are done. Calculus divided into two, differentiation and integration. Differentiation, I'm done. So now what I'm going to do is integration. Those who dodged those lessons, let us pray for you. So I'm beginning with the velocity. Velocity is the change of displacement with respect to time. Then you all know from that. So how are you going to help us who didn't attend the integration lesson? You will have, you enroll and get the recording that you actually missed for all lessons, chemistry and math 1 and math 2, chemistry, all the branches. So we all know that at this step, I introduce the integral sign on both sides, but I bring it with the dt. Deep down, someone who crammed wants to bring dx, even after seeing dt somewhere here. B equal to, do work that is best. Introduce integral signs. I will have this of dt, so dr out of t dt. A good student of integration can actually tell from this, come up with something that says displacement r is the integral of velocity with respect to time. A good student of integration can actually tell that r is the integral of velocity with respect to time. Then from acceleration, which is the rate of change of velocity, integrate. When you bring the integral sign, you must bring the with respect to. Even here, when you bring the integral sign, you have to bring the with respect to. And also from there, a good student of integration can actually tell that velocity v is actually the integral of acceleration with respect to time. So my question is, are those two formulae derived from integration also okay? Those who attended the think not even, especially theirs where this was the cheat code I gave you one time when I was teaching integration. So any questions concerning that? Yes, people who didn't attend lessons of integration, that one may disturb you a bit. So let me see those who are getting confused, even when the topic of integration was taught. That means you have not been practicing. But literally, you know the first step, that one we have just derived from definitions. The next step, I'm literally just introducing the integral sign and the dt. So I remember saying that you assume that this dt cancels with this dt, and then you know that the reverse of that integration is the reverse of differentiation. So those two cannot be near each other. So all in all, we shall see r remaining. That is this r. Then this side will remain as it is. Even here, the same thing. First step from the definition. Second step, we introduce the integral sign as we put it dt. Why dt? It is what we have already. Then this side, we assume that this dt cancels with this dt. Then we also assume that integration is the reverse of differentiation, so they can't be near each other, so only v remains in that case. So that v is what is this side. Then we just carry this side as it is. Then we just put it there. So I've just tried to review faster. Hope now there is some sense. Hope now there is some sense being made from that. If at all you have not yet picked a thing, that means you have to go back. First watch the all lessons of integration, then later come back. Okay, because this is the lesson that we are actually recording. So you like it or not, you get its recording when you actually need it. Okay. Now, after that, I think we can do our first question. But before I actually write our question, it's a question. I want your assignments to be unit numbers. Example 1. Before I put example 1, you look at all those things that we use here. The Newton's law and the calculus. Those things must be making sense. Just look at the calculus alone, okay. Because Newton's law is easy. That one is F equal to ma. Then making A the subject, such things. Those ones are not so scaring. So after looking at that, I believe that is enough time for you. Then you can also look at Newton, as you also look at part of calculus. Newton is there on top. Look at the formula, look at how I made the subject, look at how I can get the resultant. At all forces are so many and are acting on the same body, such things. Then I put my first question. Okay. Now, my question bank is a bit far. I'll need a serious person. Let me see if Ibrahim is on. Ibrahim, if you're not on, then I'm going to feel bad. He's not here. Is Sembatia. I don't know. These days you no longer attend. Don't know why. You only wait for recordings. Who has a question bank? What's the question bank as I write this example? What's the question bank and you know that you have a good camera? When you can take questions now. As I'm teaching, then you look for the questions that you want. A particle moves. What's the question bank and you have a good camera and you can take pics now. Such that its position vector. Please, you called iPhone, you leave my screen. Yes, Winnie. Now you go to the paper 2 of those first years from 2020. I don't know where QB starts from, but it would be better if it is 2022. From 2022 up to around 2016. You look for those numbers, they are in section B mostly. This person is very serious. I think you can see. 2022 number 10. You check that message in the Zoom chat. So what I want, you help me one thing, Winnie. You look for those numbers this person has posted, and then you'll be sending a picture. You take a picture of the number and you send it on my WhatsApp. Then for me, I'll pick the questions that you're supposed to do. So, example 1, they are saying a particle of mass, 2 kilogram moves under action of 3 forces. Moves under action of 3 forces. F1, F2, and F3. At a time t, F1 is equal to time t, F1 is equal to a quarter t minus 1. F2 is half t this question is serious. Half t minus 1i plus t minus 3. Yeah, these are vectors, and that is a force. So you have to put in newtons. Then we go to force 2. F2. I have T plus 2I plus I have T minus 4. J, this is a force, so you have to put newtons. Then F3, force 3. Quarter T minus I that plus 3/2 T plus 1 J. It is a force, so we must have newtons. Then the question is find acceleration. Find acceleration of the particle. Find acceleration at t equaling to 2 seconds. Yes. So you people, you must be extra attentive because this is a UNEB number. Because I'm seeing someone here sending me a direct message saying that that is 2011 number 2. Let me trust you. Let me trust you because I actually trust you. Someone is saying that is 2011 number 2. So you please follow up. So pay maximum attention. We do this one. So realize this is a number where you have a lot of forces, you have mass, and you want acceleration. So that means that for this case, we have to use Newton's law. Because now here calculus is not going to help us. Now, why do we need calculus? Because we have the forces, we have mass, they need acceleration. So it is the other thing I told you about, that when you have so many forces acting on the same body, how do you actually come up with a single force? That's why I had to ask. But now I think, yeah, I think now people can tell, yeah, why I was telling you so. So we are going to get one general force, the resultant. We are going to get the resultant and then we see. Since these ones have F1, F2, and what? When you're doing your solution, now just say that single force that we need, shall just add those ones up. Get F1, get F1 plus F2. So you people, according to this question, we need a single force. Don't ask yourself, why are we adding them? We need a single force to get acceleration. So force 1, you look at force 1. It is a quarter T minus 1. So a quarter is 0.5. So it is a quarter T minus 1, quarter T. And let me hope you people are aware that if you have something, let me say D, a vector, which is the AI plus BJ. Let me hope people are aware that this one can actually be written in column form. as A, then B. Are people aware of that? I remember teaching people yesterday this stuff. Told them this is the position vector, this is the column vector of D. Are people well conversant with that? Are people conversant with that AI plus BJ can actually be written as a column vector? Because it is what we are going to actually apply here. So literally, if you're hearing it for the first time, learn it by heart. Okay. So now we are going to do what I've just said. So for this one, I'm going to say 0.25 t, because it is a quarter t minus 1, but a quarter is 0.25. So I'll say 0.25 t minus 1. Then I go back here. It is t minus 3. So here you'll have t minus 3. It is the one for the j. Then I come and add force 2. Look at force 2. It is a half t plus 2. That is 0.5. Half t 0.5 t plus 2. Then I go to the j. A half t minus 4. A half is 0.5 t, and it is minus 4. Then I go to the last force 3. A quarter t minus 4. A quarter is 0.25. Quarter t minus 4. Then this one is 3 over 2t plus 1. 3 over 2 is 1.5. So 1.5 t over 2t plus 1. So you put here plus 1. Like that. Then I'll find the force. In piece, 0.25 plus 0.5 plus 0.25, that is a 1. Hope you can see that. That is a 1. T, which is just a T. Negative 1 plus 2, that is 1. Minus 4, that is negative 3. So I'll put minus 3. T plus 0.5, that is 1.5. Plus 1.5, that is 3. So here I have 3t. Negative 3 minus 4, negative 7. Plus 1, negative 6. Okay, so I have here negative 6. Negative 6. And this is the force, so I will have newtons there. So now I have the force. I can get the acceleration. So you people, though the question said acceleration at 2, don't panic to substitute the 2 there and then, because for you want to make your work easy. First maintain that t up to when all your calculations are done. Then you can now bring in the 2 for substitution. So I'll say that the acceleration I'm looking for is actually the force out of the mass. According to the question, the mass, you can see it was 2 kilograms. Yeah, and in paper 2 we always use kilograms. But this is a vector, so the 2 kilograms will come as a half of this t minus this, and here this minus 6. Remember, I'm getting acceleration, you understand? So at this point, you may not overdo a lot of things. After now confirming that this is your acceleration, you can actually come and do what? and substitute. Say that t equal to 2. Acceleration is a half 2 minus 3 minus 6 After that, what are you going to get? A on top we shall have 0.5 but a negative. I don't know whether people are seeing all that. Then here down we shall have a 0. So be meters. So that is the axis. That is what we have so far. So the thing is, how do we actually proceed? What was the aim of the question? The question just said, find the acceleration. You understand? So someone who writes it like that is okay. Then someone may want to be more specific. Then they will say, the answer is negative a half I. Then meters, because the other one is 0J, negative half I is enough. So even that is okay. But if the question had said magnitude, where did t equal to 2 come from? From the question. Where do we get a half at force? At force, that was, we are trying to, this is mass, yeah? M was 2 kilograms. So that half you're seeing is this M actual. You understand? Someone is telling me, pardon. Let your questions be organized. You have to ask like that person, where is a half coming from force? But if you say pardon, now pardon from where? From the facilitation. Okay. But if question says, but if the question says that magnitude of acceleration, the question says magnitude of acceleration, then that's where I have to come and say negative this one squared plus 0 squared, then you come up with 0.5. And you can see. So the questions are different, yeah? But the question that was asked, someone could either have the answer in column form or in the position vector form. But if the question had said magnitude, you go an extra mile and use Pythagoras. Yes, so I want members to tell me whether the first example is okay. I've exposed the question and the solution. It's a enable question, 5 marks. Let me see what people are saying in the chat. We leave it like the first answer. Yes, you either leave it in column form or in position vector form. So when do we integrate, sir? It's the next thing we are doing. Yeah. For this one, we are just using Newton's law of motion. Where we integrate and differentiate, you're going to see how the questions come. And you can literally tell and be like, yeah, here I have no option other than differentiating or integrating. You see those questions. Questions will come. Questions. When you say a question without force, then Newton cannot help. we proceed. Actually, the whole of next year, we are going to just be revising the whole of next year, because most of the work is going to be covered this holiday. Most of the work I want to cover, then the rest you complete from your schools. First term holiday, we shall just be revising daily. We shall have revision books. We do each and every questions. We come, we discuss daily. That one you should be aware. You should just be aware of that. Yeah. So, let's look at example 2. So, example 1, this is where we have used the Newton. Hey, someone has even sent me a number on WhatsApp. Hey, let us do that number if you want. Someone has sent in their request. I think we should respect it. Let us accept their request and do their number. Example 2. Example 2. This is where someone is saying you need 20 02 question 8. Yep, 2008 question 8. Is it saying a particle? So here I think we are going to differentiate. We are going to find out. Let me not think. I may even think in a bad way. Yet the person has sent a number of Newton. A particle moves in the XY plane. XY plane such that particle moves in the XY plane such that its position vector at any time t. The particle moves in the x its position vector at any time t is given by, believe now people know what R means, is given by R. So you people, those with question banks, you confirm with me. Is this a question of 2002 question 8? R 3t squared minus 1. This is I plus 4t cubed plus t minus 1 j. Yeah. So they are saying find speed. Then magnitude of acceleration. Then down here they say after t equal to 2 seconds, something like that. So when they put this one when they put it somewhere down, they are trying to tell you that please apply it to both. But if it is a continuation of magnitude of acceleration, then you only apply it on magnitude of acceleration. Now, you look at this question, there is no force, there is no mass. So here you cannot use what? Newton's law, because for it is mass and force, then acceleration, of course. Here what you have is R. So you just have to remind yourself and be like, R is this what? Displacement. Just have to recall that R is displacement. So I want you to note this. Note. Remember, velocity is speed, the same as speed, just because speed is scalar, and this one is what? A vector quantity. Being a vector quantity, it considers direction. And since it considers direction, for it can be a positive, it can be a negative or a positive. But this one being a scalar, this one only considers only magnitude. Only and only what? Magnitude. Since it considers only magnitude, this one can only be a positive. You can never find speed which is a negative. And you know what magnitude means. If at all you have any value, so just have it in mind that speed is the magnitude of what? Of velocity. Because for it, you know very well, if at all you have x equaling to negative or positive a, you know what magnitude means. The moment you say magnitude of a, whether it is a positive or a negative, that one will give you a as a must, you like it or not. Magnitude of a, whether it is a positive or a negative, that one will remain a, and it won't change. So if speed is the magnitude of velocity, then distance is the magnitude of what? Someone has said it. Distance, for it is the magnitude of what? Displacement. So what I try to mean that every time you get maybe a velocity, when you get a velocity as negative 21, this velocity is the same as speed. Just because speed, we don't want to see this direction. Speed is a scalar quantity. We only want to see positive answers. So for speed, it will be, if this is the velocity, their magnitude is always the same. But for them, they are only positive answers. So you simply get the magnitude. Because you very well know that these bars, the ones I'm shading in red, those are bars that represent magnitude. And you know, for them, whether it is a negative or a positive, for them, their role is to maintain a positive. If it is a negative, they cancel it and make it a positive. Hope I'm clear. So the 21 shall be the speed. If you get a displacement of -5, the distance is 5. I don't know whether you're getting that simple concept. Because you'll find a question which is not directly connected to speed, like the one we are doing. The question I've displaced does not connect to speed, but it connects to velocity. So that means after getting your velocity, tell us that speed is actually magnitude of velocity. You all know that scalar quantities and vector quantities share magnitude, but they don't share direction. So actually the magnitude of speed is the magnitude of velocity. Hope that is okay. Because both have magnitude, but one only has direction. So hope that makes sense. The person telling me to repeat my statement about after 2 seconds. After 2 seconds, that means first do everything, you leave in the 2. Then as you're concluding, that's when you substitute. It depends on the position of the after 2. There is when it is put down. That means that applied to both. But there is when it is a continuation of a certain Roman numeral. So you make it stick to that. No big issue. So I can now go to this question. So this question gave you R and it is asking you for speed. But for you, what you know, speed is the magnitude of velocity. So which relationship is there between displacement and velocity? So in simple terms, how can you get velocity from displacement? Hey, solution. You understand? They are asking speed, which speed is the magnitude of velocity. They are asking velocity and they have given us displacement. So which relationship is there between displacement and velocity? We know that velocity is the change. Velocity is the change of displacement out of the change of time. So before I proceed, people okay with my interpretation? Because interpretation matters. Without interpretation, then of course we can't have a solution. So I want to first hear from you people. You tell me in the chat whether we are good to go. We proceed. Are we good to go? Are we good to go? We are good to go. So I'm now going to substitute. Yeah? I'm going to substitute. So I will say R. Now we are going to substitute for the R. You look in the question. R is 3t squared minus 1i. Then J is 40 cubed plus t minus 1. So I'm going to write them in column form, but I'm only substituting for R. I'm only substituting for R. The rest is remaining. So what will I have hence? Hence I will have V. I will have D out of dt. And I will have my R here. In the place of I have 3t squared minus 1. Then for the I have 40 cubed. 40 cubed. 40 cubed. 40 cubed plus t minus 1. I don't know whether that is the way it is. 3t squared minus, yeah. Do you see the R? 3t squared minus 1, then 4t cubed plus t minus 1. Then here I come, I write it in column form like that. Then we differentiate, because now it is very clear that we are even differentiating with respect to t. Yeah. So is that hard? So from there, I come and proceed and say, so my v is now, when I differentiate 3t squared minus 1, I get 6t. When I differentiate the one down, I'll get 12t squared plus 1. It being velocity, I'll put my unit meters per second. So you people, are we at the same page? Are we at the same page? Are we together there? Expedia, where is the problem? I've just differentiated with respect to t. I've used the basic rules of differentiation. Don't just say no. You say no, but with a relevant question attached. That means you don't know differentiation. Then that is a very long journey. If you don't know where, did you study differentiation? If you didn't study differentiation, then it's going to disturb you. Because we simply drop the power and reduce the power by 1. That's what we do. Drop the power, so you drop the power 2. When it multiplies the 3, it becomes a 6. Then you reduce the power by 1. So it transforms from t power 2 to t power 1. I know they're getting me. So for the case of 4t cubed, you drop that power. It becomes 12 because of 3 times 4. Then you reduce that power by 1. That's why it becomes t power 2. That's what is done in differentiation. So after that, remember they need the magnitude of velocity. You cannot get the magnitude unless you at least substitute. So you come and say at t equal to 2, v is equal to 6 times 2. Why do I even use times? I'll use my simple brackets and I'll say 12 into 2 squared plus 1. Then finally, I will get my v as, this is 12 and this is 49. Those who have calculators, 49. So after getting that velocity, I come and say that my speed, the one you guys are looking for, you guys are asking for, is the magnitude of velocity. Don't forget that vector symbol. It being a magnitude of velocity, 12 squared plus 49 squared. So the speed shall be those with calculators. Let me press very fast here in my calculator. Root 12 squared plus 49 squared. I'm getting 50. You know me, I'm a fan of 5 dps. Yeah, I'm a fan of 5 dps for reasons you all know. 50.44799. Do the unit remains the same. That is the answer. I saw someone comment about how we have calculated for our speed. Someone comment about how we have calculated for our speed. Because now the next thing we are doing is the magnitude of acceleration. Magnitude of acceleration. And after that, we shall do one car number. Only one car number. And then we shall call it a day. The rest shall be your numbers to do. Yeah. So any questions about how speed has been calculated? Doesn't the word after have many meaning? Just a matter of substitution. No meaning, just substitute. Yes, after t equal to 2, that means t is 2. Calculation is okay, calculation is okay. So more people to comment about that. Can we go to now acceleration? Because now the question is asking for the magnitude of acceleration. So to actually get the magnitude of acceleration, we shall need the acceleration itself first. After getting the acceleration itself, now we can proceed and get the magnitude. Yes. So you know that we had the velocity. So Roman 2, is it Roman 2 or part B? Let me take you back. So it is part B, they wanted magnitude of acceleration. But you all know that acceleration is the rate of change of velocity. Those are things we actually can with. Acceleration is the rate of change of velocity. And when you look at our previous calculation, of course, you cannot use this velocity which is substituted for. You cannot use that one. Now, what are you going to differentiate? You have to come for this one. Because this is the acceleration at time t. So that means that as we are differentiating with respect to t, this is what we need. So we shall need this velocity, and this is the velocity we are actually going to differentiate. 60 on top, then down we have 12t squared plus 1. So we now come and substitute for v and say acceleration. This one will remain ddt of v. What is v? Saying that is 60. Down we have 12t squared plus 1. Then when I differentiate 60, get 6. Differentiate what is down. When I differentiate what is down, I actually get 24t. I get 6, and this one 24t. Put the unit for acceleration as that. And they say they want the magnitude. You cannot get the magnitude unless you substitute. So you come and say t equaling to 2, acceleration 6, and this is 24, 2. The acceleration will be, this is 6, 48. That is it. But they wanted the magnitude. I have to come and get the magnitude. These are all things I briefed you about before we actually started calculating. So I don't expect them to be an issue. So the magnitude of acceleration, I'm a fan of 5 dPs. So I'll come and say 48 squared plus 36. I get the root of my answer. So I'm getting 48.3735. Not forgetting the unit of acceleration. Sorry for that. Let me bring back the screen. That is it. So that is it. That is our beautiful correct answer. So I don't know if people have questions. Let me pinch for you, just try to follow up. The way I'm presenting this work, it is the same way you're supposed to present if at all it is an exam. Provided it is an exam, the same way I'm presenting is the same way you're supposed to present. Period. Yeah. So you have seen that example 2 has been demanding us. So people, you comment on that part of magnitude. Is it fine? Is it okay? So it is this one has been demanding us to actually differentiate. So we are now going to do that one that asks us to integrate. That one, let me use mine. People, you have over suggested, let me use mine. It is also in a question of just recent. So this is what requires us to use calculus, but as we are differentiating. Only people, let me tell you this. If you actually know that integration is the reverse of differentiation, just give you a verbal cheat code, which you can only understand as I speak. If you just look at it, it may not be clear. If at all you know that, yes, velocity is the rate of change of displacement, you know that there it is differentiation. What is that? You know that it is the rate of change of what? Displacement. That means, hence displacement is the integral of velocity with respect to time. You understand? Without even doing a lot of the other steps. Then if you know that acceleration is the rate of change of velocity, which is differentiation, then the reverse is true. And then the reverse is true. But now velocity is the integral of that one with respect to time. So what is hard there? Really, what is hard? If at all you cannot go through the other steps, at least recall the definitions. You understand? Just recall the definitions. Acceleration is the rate of change of velocity. That is differentiation. That means, hence, velocity is the integral of acceleration with time. If velocity is the rate of change of displacement, that means displacement is the integral. All of them are with respect to time, with respect to time. Or if you can't remember that, then you go back to the basics. And with the time, I assure you, this formula will become direct. I always tell you that these first lessons you're here to appreciate. When you do when you go back and revise, you understand, hence you do assignments. Then after assignments, when you visit again, you're now on the journey of mastering the concept, because even assignment you can't forget. When do we know that we need to differentiate or to use equations? Is it t when there is a term in t? Oh, of course, that was what I began with, that we are talking of variable acceleration and variable velocity. So that's why we actually, what you're talking about of using equations, that is when the velocity and acceleration are constants. But here they are variable because we have t in them. So calculus and Newton's law come in. Then if at all they are constant, I'll also share those questions, you will see. There I just use equations. Here equations may not be of help. If you try to use them here, you may take the whole day. Yeah, that one I assure you. Okay. Example 3. Example 3, we are going to use UNEB 2014. 2014, question 2. And I've said we're also going to identify, you're going to see that we are going to be supposed to integrate. You see, people are blessed academically in different ways. There are people who are good at cramming formulae, but they cannot be in position to understand them. That's why I always don't want to over delay on something. But there is someone who has just crammed all the 4 and they cannot forget for the rest of their entire life at 11, which is okay. So we are saying a particular car starts from rest at the origin. It is 0, 0. Its acceleration in the unit, especially when you see these things of time t seconds, is given by a equal to 6t I minus oggi Find its speed when t is 2 seconds. Yeah, something like that. So now you look at this question. As I always tell you, the question is asking for speed, but we have not talked of speed anywhere. But we know that speed, we can actually get it from what? Magnitude of velocity. So you ask yourself, what is the relationship between acceleration and velocity? What is that relationship? We know that acceleration is the rate of change of what? Of velocity. By this time round, we need to get velocity from acceleration. So if acceleration is the derivative of velocity, that means velocity is the integral of acceleration, all of them with respect to what? Time. So this is what I'm going to use. So to get velocity, I'm going to integrate acceleration with respect to time. So I want to ask people whether they have understood my interpretation before I go any further. Have people understood my interpretation before I go any further? Do people know the reason as to why I'm going to integrate acceleration to come up with the velocity, whose magnitude is going to be the required speed? Okay, so people are following. That is nice. Emax, I answered your question, but you didn't reply that you got it. So it is 60i minus 4j. So as I'm doing my solution, so that my acceleration 60i minus 4j, so it is like that. So when I come to get velocity, I can first show them that this is the integral of that with respect to time. Then I get the integral 60 minus 4 dt. So when I integrate, who are good at integration, you know what I mean. Now these numbers, you must be serious. Hey, very sensitive. I even regret ending with them. I literally had to transfer them to the next lesson. But those of you who are here, let us respect your time complete. So when we integrate, I don't know whether people know integration. Now integration here, what we do, we increase the power by 1 and we divide by the new power. Like for this case, t is to power 1, so I'll increase the power by 1. It becomes 60 to power 2. Then I will divide by the new power, which is 2. Even down, t is present, but it is t to power 0. You know t to power 0 is 1. So I will increase the power by 1. It becomes t. When I divide by 1, it will remain that. So are people fine with that? Then every time I integrate, I should add on the constant of integration. So are people fine with that output? Hey, now serious work has just started. I don't know if you people are ready. Plus a constant of integration. Are people there with me? Are people there with me? Are people there with me? Pardon, on negative 40. Okay. Now, negative 40, t is present because we are integrating negative 4. So t is there, but the t which is there is silent. How? It is to power 0. So as I'm integrating, I will have to increase the power by 1 from t to power 0 to t to power 1. Then I divide by the new power 1, but you know anything divided by 1, it remains that thing. So I'll have negative 4t to power 1 divided by 1, which is negative 4t. You get it? Maybe you throw some light on the constant. Then for you, just don't know the basics of integration. A constant of integration is supposed to always come. You must always add it. Every time you integrate, that constant c is supposed to be added as a constant of integration. Meanwhile, just take it at that. If you need the recordings for integration from the beginning up to the lesson we are on, I think we're on lesson 10. Then you just enroll. Just enroll and get all you want, period. Yes, of course, all that was taught in definite integral. But even if it is definite, you first handle it as indefinite. Then you later bring in the limits. After removing the integral, the constant is introduced. Yes, exactly. That's what I say. So from there, and now I'm going to tell you something. Since we are dealing with the vectors, even this constant of integration for this case is a vector. The day you will forget that tilde on C, that will be the end of you. Very many people have a tendency of forgetting to show that even that constant of integration is a vector. And very many fail. Very many fail from there. So always remember that even the constant of integration at that case is a constant. So you come and now summarize and say now this is 3t squared. This is minus 4t plus the c, which is also a vector. Now after that, remember for us, we don't want to deal with that constant. So we fight hard to eliminate it. What do we actually do? We go back to the question. What is the question saying? The question is saying a particle starts initially from rest at the origin 0, 0. That's what I want. That the particle starts at rest at the origin 0, 0. So you have to, that is initially. So you come here and say initially, t equal to 0. Before we start counting, it is t equal to 0. The car was at rest. Hence, the v, which is the velocity, is also going to be 0 and 0. I'm writing it in vector form because that is the form we have. Why is it 0, 0? Because actually the car was at what? At rest, not moving. So even the v was 0, 0. Why am I calling the time? Why am I calling the t 0, 0? Because we had not yet actually started counting. It was just there at rest. That's why they are saying at the start. So that means initially t is 0 and also our v is 0, 0. So I'm asking, does this statement make sense? That is the statement of the day. If that statement makes sense, even if you end the lesson from here and go and rest, precious Aine, you leave my screen. You leave my screen and do other things. You are just putting a lot of dots distracting us. You leave the screen, please. So you people, do you get what I've said? Do you get what I've said? Because that statement matters a lot. Without that statement, you cannot get other marks. Do you know where the t equal to 0 is coming from? Do you know why I'm saying v 0, 0? I'm saying t is equal to 0 because I've said these things are actually happening initially at rest before we have done anything. That means t is a 0. Why is v velocity 0, 0? Because the car is at rest, so it is not moving. So velocity is a 0, but I'm putting it in column format because that's what we have. So let me hope now those who had said no, it is now okay. Yes, because at first there was no motion. Good. So I will come and say, I'll come and now substitute it. Say v is 0, 0. Then here 3, 0. I'm now substituting. I want to get the value of c. Negative 4, 0 plus c. Not forgetting it is a vector. So from that, I really get my c as 0, 0. So after obtaining c as a 0, 0, then I conclude and say, hence, v now is 3t squared negative 4t plus 0, 0. It remains like that. Then I put a unit. This math is very important and many people miss it. And after missing that math, that's how they lose most of the marks. That math, from setting those initial conditions, you get the value of the arbitrary constant, which is a vector. Then you conclude with the corrective value of velocity. That is one of the things that actually give people hard time. So you people, you look through that solution. For integration, things are serious. First and foremost, you must know the basics of integration, because now they need speed. And here we are with our velocity. That means we are done. Because when we get velocity, then we have hence speed. So any constant, because now the next thing, they said at t equal to 2. So the next thing is to substitute for t and then get velocity, get its magnitude as the speed. And that is all. Yes, speed is magnitude of velocity. I've not said the question is done. I'm asking whether we are at the same page before I proceed. It is me who interpreted the question. So if we are at the same page, we proceed. I've said the remaining part is just substituting for t equal to 2, get the velocity, obtain its magnitude as the required speed. That's what I said. So I'll come and say at t equal to 2, the v shall be 3 into 2 squared negative 4 into 2. Then what am I going to get as my v? I have 12 here. I have negative 8 is my square meter. So that is my velocity. So I get the magnitude the magnitude shall be the speed. Come and say the speed magnitude of velocity, not forgetting that vector symbol of 12 squared plus negative 8 so the speed is, those with calculators, $14.42221. Yeah, what is that? So that is the speed. Very. Those initial conditions, respect them. Especially this hence part, we must understand that from there, that's where I went to the hence part. But those who actually follow the voice will get it too. Can we write 4√13? Yes. When the origin is not 0. What if the rest point wasn't the origin? Then things change, subtractions come in. Yeah. But those are concepts that are going to come along as we practice. I want now to give you a question where the rest point is a 0. Then a lot of questions are going to come up where the rest is not a 0. But that will be later. You cannot just cover everything, but there you simply subtract. Yeah. I think I can give a number. Can give a number that has some trigonometry. So I want people to try out this number on your own. Because I think given you the best of the introduction, the rest of the things you can actually interpret if you have been following assignment. Question 1. So that particle, I will not put the years. Most of you have solution books, so you may end up copying. So a particle of mass 2 kilograms, particle of mass 2 kilograms. Initially, a particle of mass 2 kilograms, initially at rest, at 0, 0, 0, is acted upon by the force 2Ti plus Tj plus 3Tk, because it is a force. T is not supposed to have. So those who studied the vectors yesterday, the K shouldn't scare you. saying find the acceleration. So you people, these are the things. Imagine, you see, you have the mass, you have the force. How can you fail? Get acceleration. Really? One, acceleration. They want acceleration at time t. Then after acceleration at time t, you see what they want, velocity. So the question should be, what is the relationship between velocity and the acceleration? So they want velocity after 3 seconds. Next time they will say after t equal to 3. Yes, they have just said after 3 seconds. Then third, they're asking for distance. They're asking for distance traveled after 3 seconds. But you know, we don't have a relationship between distance and velocity. The relationship is between velocity and displacement. But you also know that distance is a magnitude of displacement. So even that one can be done. So you ask yourself, how is velocity related to displacement? Then you ask yourself, how am I going to go about that? This is a very good question. And this is what UNEB sets. Now imagine these are 12 marks. These are 12 marks. 12 marks. Acceleration at time t, velocity after 3 seconds, distance traveled after 3 seconds, particle of mass initially at rest. So you people, I don't want you to be confused by those mene, like the K. We have not done any example with K, but it shouldn't confuse. Just treat it the same way. It is going to be the same column with 3 rows this time round. How does subtraction come in? That one we shall learn. How do we deal with K? It's also another point. You put it under J value. Yes. Do we leave in our K as a constant? It's like A and J. Yesterday's recordings already in the group. You people, this is what I'm meaning. For example, when you have your vector, maybe vector Q, I plus B, J plus C, then K. So Q is now having 3 columns, A, B, then C. Then that is it. So as I told you, this I represents the x-axis, then the J is the unit vector representing the y-axis, then the K is a unit vector representing the z-axis. So that's why I'm saying that shouldn't worry you. Just treat it the same way we have been treating the others, just because here we instead have 3 rows, not like the 2 rows we have been dealing with. Hope that is okay. So this is like a hint for the question, because I'm not doing any more numbers, just assignment and giving you the hints, period. Now number 2, also yours. So those who have questions, you can be meanwhile bringing them up. Yes. Now, I'm going to even ask you trigonometry. I see whether people can try, because I literally taught trig, integration of trig functions, differentiation, trig functions, so people can try this. A particle of mass 3 kilograms is moving on a curve, So you people, these questions mean a lot. If they are done, that means the topic will be 90% dusted. Described by R equaling to 4 sine 3t I plus 8 cos 3t. I want to see whether people can actually apply that knowledge. Applying knowledge of trig and knowledge of what has been taught today. That would be a success. So yeah, they are saying where R is the position vector, where R is the position vector of the particle, where R is the position vector of the particle at time the time t equal to 0. But is my friend Amos on? I doubt. If you're on, may God bless you, sir. Me, I knew you were not on. Nakato Lois, you have been on up to this time. May God bless you. Anixike, same. I didn't know that people could reach this time. Okay. Roman 1 saying determine position vector I taught yesterday, so I don't want you to be confused when they ask you for the position. Saying you determine position and velocity. So you ask yourself, what is the relationship between velocity of the particle at t equal to 0? Then Roman 2, they are saying show that for sure. I want someone to do for me this number. I want this Roman 2 to come out. I'll give you some money as a present. Acting on the particle is negative 27 R. So this number is actually healing. That's the money I always give. 25K. But when all your steps are correct, the moment I put money, I be so strict when looking at your work. So chances are that I will have to have that money. You're asking which year. Thanks for the appreciation. You're asking which year so that you go to the solution book. No, sir. No, sir. So those two questions are enough. We shall see another concept when actually when you have become old enough. So that is the end. I think even my pastor Bridget, teacher Hede, put the whole question at once. Show us the question again, scroll and I see the question again. Okay, let me first write this. So this is the end, and our online school where we do most work from is called the Chemistry and Mathematics Online School, abbreviated as CMOS. Yes. The patron, if you want to talk to the patron 0753 279592, and I'm the patron. That is Airtel. MTN is that. Yes, that is my signature. In case you want to join our lessons, we basically break down the math and chemistry for you. So those who want to see the question, that is it. So I'm going to share this PDF, this document we have been writing in. Just don't be worried. Yeah, I'm also going to share the recording. Yes. So that is the question, 25K. That is the prize. Even add it here. That is the prize. So unless someone has a concern, but otherwise, I think that is the end of the facilitation, unless someone has a burning issue. But that is the end. So as you go off, don't forget to thank me for the lesson here on Zoom, on WhatsApp, and also post on your status. You invite your friends to come through and join us. Yes.
Ay, man. Bathini bona. Ngeke bona. Bathi babeka amaphiya phezulu bona. Hayi. Wasabe wena. Hayi wena man. Hey. Bathi phela amaphi yesayiti. Hayi babeka phezulu lemaphi. Hayi jima makonye kepali. Sesafakile layini. Bathi phela amaphi yesayiti. Babeka phezulu lemaphi. Jima makonye kepali. Sesafakile layini. Bayiqedile izolo. Hayi bonithi jima ngomphingo. Hayi papa seyibhenyiwe nezolo. Amaphi yaphezulu. Hayi bayiqedile izolo. Hayi bonithi jima ngomphingo. Hayi ungaseyibhenyiwe nezolo. Yaphezulu.